Right, okay, so we're looking inside. You will find dust, in this case, quite a lot actually. If I move the fan, there's quite a lot of dust on that fan. Right, so these are the components inside. This is the part where we attach our optical drives. So this is the DVD drive, this is the CD-RW drive. Down here is a little caddy that's got two hard disks plugged in. Okay, down here you can see that's the little PC speaker that does a little beep when you turn a computer on, and this is a little set of connectors that just connect the USB sockets and the lights and the switches on the front through these cables to the motherboard. Okay, and there's various little sockets on the motherboard for plugging these parts in. If we can zoom down here, on most PC motherboards you get these like sets of pins, and this is where all the little connectors for the power, for the hard disk light, for the reset switch, for the PC speaker, this is where they all go. They're not plugged in on here. You can see that on the end, on a decent set of cabling, you will get named connectors. So you can see we've got power switch, power LED, hard disk drive LED. Okay, there's the speaker one. It's funny, on some PCs they're not labelled at all, and it's actually quite confusing because down here they might have very, very, very small writing or no writing at all, so you might have to like look up the manual for the motherboard. Okay, now you can see there are 3 fans inside this. Well, the 4 fans actually. There's one here on this main circuit board, which is called the motherboard. This is where all the major components are stored for the computer. You'll also see that we've got sockets for connecting what we call daughter cards. Okay, mother and daughter. I don't know why those names came about. They've just been adopted. And you can see the graphics card from the inside now. Okay, and the graphics card's plugged into a socket called an AGP socket. Advanced Graphics Port is one of the names that stands for. But we have actually got some other sockets here, PCI sockets. Now you won't tend to find PCI sockets on modern motherboards. They mainly use PCIe, which is what the graphics cards plug into these days. So even AGP is an old standard. Things change quite a lot. And it can be quite confusing when you're messing with PCs, that sockets change, standards change continually. But that's computers for you. Okay, so we look at the fans. This one here is for taking heat out of the computer. Again, this is one I bodged up because this computer was getting very hot. That was another one that was used to extract heat from the computer. This fan is sitting on a big piece of aluminium called a heat sink. Okay, and a heat sink is to enable heat to be transferred more efficiently from a device. This is sitting on top of the CPU. Okay, so this fan is to extract heat from the CPU because CPUs, the main brain of the computer, gets very hot. But we've also on this motherboard got another fan, a little fan, and that's sat on the controller for the motherboard. That gets very hot as well. So the controller of the motherboard directs all the traffic, all the signals that are going through all the different components, and that gets hot. Okay, you'll see up here we've got all those sockets that were on the back. So we've got the parallel, we've got the USBs, the audio sockets, etc. And they're all connected, you can see, directly on the motherboard. So when we say this machine's got onboard sound, that's what we mean. It's directly connected. There isn't an extra card. Okay. In the top you can see the power supply. Now this is the fundamental part of a computer. If you haven't got a power supply, it isn't going to work. And you can see coming out of the power supply is a ridiculous number of cables. Now these are supplying different voltages for different devices. So you've got 3.3 volts, you've got 12 volt cables, you've got 5 volt cables coming out of there. In general the drives need 12 volts, but they also take 5 volts as well. Things like the graphics card, that gets most of its power through its connector, but you'll see that on a lot of graphics cards they have additional sockets for plugging in power cables, so they can draw extra power from the power supply. The massive one, the ATX connector, that is the main power, and it goes in that little socket there, main power connector for the whole motherboard. Okay, that has got a very clever socket called a Molex, and all the little, it's a bit like one of those early learning centre, putting the shapes through the holes. All the holes are different shapes, so you can't plug it in the wrong way around, because if you did that you would fry the motherboard. Okay, not good. Right, so you'll see that the hard disk drives and the CD and DVD drives have got these small power connectors, which supply 12 volts and 5 volts to power the disk drives and the logic. The 5 volts is for the circuit board that's attached. If I just tilt that, you'll see a circuit board. There's a controller for the hard disk. That needs 5 volts because most computer logic uses 5 volts. 12 volts is for the motor that spins the hard disk. Okay, so each one of those has to have one of these, and this is why you end up with lots and lots of cables coming out of your power supply unit. Okay, you'll also see on the hard disk that we've got this massive ribbon cable, looks like that on the end. It connects to the motherboard down here. Okay, we've got 2 sockets. These are known as IDE sockets. Now this is, again, this is a legacy socket, because this is an older computer, the hard disks are IDE, and you have these parallel cables. There's between 40 and 80 wires in that cable. I think this is a 40 wire version. Okay, and that supplies the data from the hard disk drive and allows data to be sent to the hard disk so we can save things. It's a very bulky cable and they're not easy to twist, and you can see that this cable is actually plugged in to 2 hard disk drives. Okay, and it has to go and connect down here. Now when you've got lots of pins, they can easily be bent. So what we've found in the past when students have been building PCs is that by the time we've finished, they've destroyed the motherboard sockets for the for these. I'm not going to plug these in now, but you can see they've got these, all these pins. They're keyed, so you can't put them in the wrong way, but it doesn't always stop people trying to do that. Now, there is a better cable system, and on this motherboard you can see down here, hopefully, you see that socket? Yeah, that's what we call a serial ATA socket or connector, and that allows us to connect more modern disk drives and CD-ROM units with these cables, which are a lot thinner, a lot more flexible. They're actually what we call serial cables. Now you'll need to know what the difference between parallel and serial is. You can see just by looking that there is a difference, but you need to look that up. I'm not going to explain that in this video. But serial's got an advantage. It's the same serial that we use for USB, Universal Serial Bus. Okay. One of the big problems we have, and you can see that I've got all these fans in here, is heat and airflow. All these cables, these fat IDE cables, they can cause problems with airflow. Serial ATA, as a minimum, makes a difference for that, because these don't take up as much space. You can tie these cables off a little bit easier. Okay, so you've got an IDE set of cables for the hard disks in this, and you've got them for the CD-ROM units as well. So you've got these horrible fat cables. What you'll also find on a CD-ROM unit is you need audio cables, and these plug onto the motherboard, okay, into the audio components. I can't find the socket for that. Oh, it's down here. Okay, and again, it's a bit messy. It plugs in, but then you've got a cable trailing across and leaning against all your cards. Ideally, you should cable tie, and you can see some of these things have been cable tied, and wrap up and try and keep the airflow free for the fans to try and get the heat out of the computer. Okay, so we've covered most of the components. There is one thing that we haven't covered, and that's the computer's memory, or RAM. Okay, just pump that again. Right, that is on this motherboard. in these little sockets, or DIMMs, dual inline memory modules. That's what RAM looks like. Okay, it is, again, it's sort of like a little daughter card again, but it has its own dedicated set of sockets for us to insert, and these are unforcing sockets. So you push the memory into the socket, and you can see that it's not necessarily very easy. Okay, I'll spin it round. They are keyed again, so you can't get them the wrong way around. You get to see my bald head when I'm doing this video. So we put that in, and then there's little locks. The memory is where the computer stores all the program code and all the data it is processing. So any programs that you've got stored on your hard disk, in order for the computer to actually execute those programs, they have to be transferred through the cable into the computer's RAM. Okay, and you can see that the motherboard is like the center of everything, and it's the most important component. Right, let's try and get this fan off and this heatsink off, so you can see the processor. Now, not always very easy to do on these computers, because the heatsink is really trapped sometimes. There you go, it's come off. That's how easy it's come off. And you can see it is just a slab of aluminium. It's got a copper bottom, and it's got this like goo on it. And now what this is what we call thermal paste, and it's designed to transfer heat more efficiently than just pushing the metal against the top of the CPU. So this is the CPU. This is an old CPU. It's an AMD 3000, I think. Yeah. This isn't the CPU. This is the like little card that the CPU sat on. The CPU is that tiny thing there, and that's probably got 500 million switches called transistors on that little CPU. It's got a very special socket, and these sockets change all the time. The modern ones have got 1,000 pins, but you can see on this one, there's the socket, all those horrible pins. On the back, that is the connector. But a more modern CPU has got more pins. Okay, this had 462 pins, but we are up to like 1,000 now. Very, very, very easy to destroy. We've never let students plug CPUs in. Oh, we did once actually. If I just put the back, it's got a zero insertion force socket, so there's a little lever locks it in place. Okay, and that really is a basic tour of the PC. These little things you see, these little cans, they're capacitors. They're normally there for filtering and smoothing signals that are going around on the motherboard. Okay, and that's it.